Hello, everyone, and thank you for joining us for today's webinar, where we'll be focusing on secret scanning, unmanaged secrets discovery. My name is Connor Beechinall, and I'll be your moderator for this session. And today I'm delighted to welcome Ignacio Hernani, who's on our solutions engineering team here at HashiCorp, and he'll be your presenter today. In terms of housekeeping, if you do have any questions throughout the session, please ask them via the chat or by clicking the Q&A button below. We'll answer those at the end of the session. We also have a number of polls during this event, so please be sure to give your answers in the chat. Just to let you know, we'll be able to share the recording and the slides with you after today's session. We'll do that by email, and that usually takes about 48 hours. So with that, let's get started. Over to you, Ignacio.
Thank you very much, Connor. Hello, everyone. As Connor said, my name is Ignacio. I'm a solutions engineer at HashiCorp. And well, it's my pleasure to be here today to talk to you about Vault and secret scanning with Vault Radar. So before we start, I just wanted to see a little bit the audience that we have today. So I have here two questions for you. First of all, what team are you on? And then understanding also about your state. Does your organization already use a secrets management solution or not? If you can please just answer those in the chat, we can get a better idea. Okay, without further ado then, let's get started. So at HashiCorp, we have several solutions that underpin what we call the infrastructure cloud. And we divide this solution mainly in two areas, infrastructure and security. So infrastructure lifecycle management and security lifecycle management. Today, we will talk mainly about security lifecycle management and what is probably our most well-known solution in this area, which is Vault, and more specifically about HCP Vault Radar. So Vault in general is all about identity-based security for secrets and encryption management, and it addresses four key use cases. The first of them, secrets management, then certificate management, key management, and data protection. The foundational use case for Vault is secrets management. And we will say secrets, we mean a piece of information that is used for authenticating into a workload. And it can be either a plain text username, password, API keys, PKI certificates, or even hard-coded firewall rules. These secrets can be at the same time either static and long-lived, with which Vault can manage itself, or they can be more dynamic, where credentials are short-lived and ephemeral. And Vault supports both types of secrets, and of course, we always encourage rotation of them. There are other use cases for Vault, but like I said, today we will be mainly talking about secrets and more specifically about static secrets. But let's dig into what we really mean by lifecycle management. I talked about infrastructure lifecycle management. I talked about security lifecycle management. The reality is that when it comes to secrets, storing and securely accessing those secrets is really just only a part of the battle when it comes to reducing the risks as a business. So the best practice in reality is to consider the full lifespan of your credentials. And with Vault, this starts with figuring out what secrets you have living out there in your IT estate. While you'd love your developers to always use the best practices for sensitive data, the reality is that you probably have a lot of credentials living in your code repositories, internal documentation, and communication tools. By using Vault Radar, you can scan your code and other repositories where secrets might be living unsecured and in plain text. And then Radar will help you detect these secrets with a low false positive rate and prioritize action based on if the secret is currently actively being used or if it's already been stored in Vault. And once you've identified where your secrets are living, you start storing these secrets, certificates, and keys securely in Vault. You can always enforce a least privilege architecture where only the people and applications that need access get access. So again, today we are focusing in a part of Vault, in an area within Vault, and it comes mainly to the inspection part. So here I also maybe want to throw another question, which is, do you have a sense of how many credentials are living in plain text across your text? Again, here are many of the enterprise capabilities of Vault. And like I said, today we will be talking about the scanning side with Vault Radar. And why is this important? Well, cloud leaders answered in a survey that passwords and credentials leakage were the #1 risk for them. And there is a good reason for them to be concerned about this. Verizon reported that 9 out of 10 web application breaches consisted of stolen credentials. The report also shows nearly a 4 times increase in breaches over the past couple of years, with 3 out of 4 of those breaches involving a human element. So this is why secret scanning is so relevant nowadays. And when it comes to secrets in general, this is how we look at it when it comes to Vault. We have all types of secrets, both managed and unmanaged. The managed secrets are represented as vaulted, one layer below. Ideally then, those secrets would be rotated frequently instead of being static for long periods of time. This would be another subset within vaulted secrets. And then, when possible, we always evangelize on using dynamic secrets, which are generated only when they are needed, and they have very short lifespans of just a couple of minutes or hours. And again, today we're talking about Vault Radar, and Vault Radar operates here on the top layer of secrets, which are, let's say, outside of Vault. And those secrets could be either long-lived credentials, or they could be past versions of a secret, or even worse, a current version of a secret. They could be leaked or insecure credentials, and they might be just in plain text. So here we have a few other questions to get to know the audience. First of all, does your organization already use currently a secrets management solution? And also, how many secrets management solution, in case that they do, does your organization use? Is it one? Is it two? Is it many? Sometimes we see that because of the different cloud providers, companies are using more than one secrets management solution. So please just write on the chat again, depending on what's your case. Okay, we see some people already using Vault. That's fantastic. And Vault as well as the AWS Secrets Manager. Amazing. Okay, then some people are already familiar with Vault. That's great, because Vault Radar is something that is relatively, in terms of Vault history, new. So you might want to know about all of its capabilities. When it comes to the challenges of managing all of these secret sprawl, we find 3 different areas. And well, first of all, let's go a step behind. What is secret sprawl? This is what we call to this situation of having secrets scattered across many places. You might have them in your secrets management solution. You might have them someone in your team in plain text on their notes, maybe on a post-it. So this is what we call secret sprawl, and this increases the risk of exposure. So in order to address this, we must tackle 3 top challenges. The first of them is proliferation. So in today's multi-cloud and multi-app architectures, devs can hardcore secrets in many environments, from Git sources to collaboration tools such as Slack, and even maybe on their multi-cloud environments. Then we have prioritization. So once we have those exposed secrets and these exposed secrets have been identified, the teams need to focus on remediating those exposed secrets, but everything cannot be a top priority, right? If everything is a priority, nothing is a priority. And there's sometimes even false positives, and this creates a lot of fatigues within the team. So we need to prioritize which exposed secrets we should address first. And here, Vault Radar, it becomes very useful. And lastly, well, we should, in the first place, try to prevent this situation from happening, right? Why do these secrets get into the code in the first place, into the repositories? Why are they exposed? So the best approach is to prevent these secrets from ever entering the production environments in the first place and catching those secrets before they hit production. And for that, we will see also how Vault Radar can do so and how we tackle again those challenges. When it comes to proliferation, we scan a variety of developer tools across the different cloud service providers, and also using both SaaS-based as well as on-premise scanning solutions. Then, in order to prioritize, we have many data points that we take into account, and we integrate also with different systems to check whether this exposed secret is actually in use right now, in which case we should prioritize it, or maybe it's already expired and not in use, in which case it should be deprioritized. And when it comes to prevention, like I said, we are able to scan the pull request and notify developers of any exposed secrets before they merge the code into the main production branch. So like we said, we prevent this in the first place from happening. So starting with proliferation, HCP Radar can scan the most common data sources from CLI with a CLI version of HCP Vault Radar to a SaaS version of Radar. We can scan Git-based code versioning solutions, as well as Jira, Slack, Confluence, and many others. We will see later a short demo where, for example, the Confluence one is shown. So we scan all of these data sources, again, Git-based. We support Bitbucket, GitHub, GitLab, and others. And once we scan them, we review them, right? So when it comes to reviewing those secrets, we take into account different parameters to determine a risk profile, let's say, of each secret. The first of them is the activeness. So when HCP Vault finds a credential, it will call out to the associated application to check if the secret is still active. And as of today, this can be tested for Google Cloud API keys, AWS credentials, JSON Web Tokens, as well as the personal access tokens for GitHub. We also take into account the entropy, or which is a fancy way of really saying the randomness of these secrets. We know that certain secrets have look in a certain way, right? And HCP Vault Radar evaluates the content for random or complex strings, which frequently indicate API keys or user access tokens. And once they are identified, they are then prioritized, like we will talk about, like we are talking about. We also take into account version control. So HCP Vault Radar determines if this exposed secret that we have found is used in the current version of the code, or maybe not anymore. So a higher priority will be assigned to those secrets that are being used in the current version of the code. And you don't really need to be a Vault customer in order to leverage HCP Vault Radar. But if you are, of course, you get stronger detection with Vault. For remediation, we know secrets can be sensitive to change. So we also integrate with your current remediation workflow instead of suddenly changing a secret without notice, which could break some things, right? And of course, Vault helps security teams meet compliance requirements by establishing great traceability. So here's another question for all of you, which it comes to false positives. I've talked about this already a couple of times. A false positive is basically when a secret scanning solution finds a secret that is not really a secret, and then this can waste the time of your teams. And this is where, first of all, this scanning of system within HCP Vault Radar is very accurate, and it reduces the false positives to the minimum in the industry. But not only this, because of the prioritization, it makes sure that your teams are not losing time. So when it, again, the question that I want to make is when it comes about thinking all of the personas involved into tackling an exposed secret, how long do you think it takes in your organization nowadays to resolve a false positive? So sometimes this can be in the magnitude of days or even weeks in the worst of cases. So this is why minimizing these false positives is so important. Okay, so like we said, once we have identified all of these exposed secrets, we want to remediate this exposure as quickly as possible. And this is where the Vault integrations come very handy. HCP Vault Radar integrates with the common developer workflow tools in order to facilitate remediation. So probably your organization is using some of or all of these tools, right? Slack, Microsoft Teams, Jira, ServiceNow, Splunk. So, for example, for notifications via Slack or Microsoft Teams, Vault Radar can send a message to John saying, "Hey, John, a secret has been discovered. Um, it's in this location. It's currently active and in the most recent version of the code, and it's in plain text or not, etc." So it sends all of this information, and of course, it sends it securely. And then also it can get involved on ticketing systems such as Jira or ServiceNow to make sure, again, that these workflows within your organization are respected and a secret is not changed suddenly if that's not what's desired, right? And finally, prevention. We said we want to, in the first place, prevent these secrets from hitting these public code repositories or other places in the first place. And for this, HCP Vault Radar integrates with both GitHub and Bitbucket in order to prevent these secrets from being released. So we have this integration will alert before the pull request is being merged in the case that it contains a secret. And again, it can send notifications via the several integrations that we have talked about. And they include all of the details about the type of secret, the location, and the priority, right? And by default, all of these pull requests are not blocked. Again, we don't want to break things, but if this is very high priority for you to avoid, you can configure it to block the pull requests from being merged in case that they contain a secret. So now we will take a look at a demo on HCP Vault Radar and some of the use cases. So this is my environment, but for the sake of a more visual and realistic approach, I will put on this video demo. So you can
Here I am logged into the HashiCorp Cloud platform, and I'll select HCP Vault Radar from the menu. The first thing that I see once I'm in is an overview dashboard with the latest scan results from all my managed data sources. The information is categorized and ranked based on level of risk. So as an AppSec team member, I can quickly see where I might have issues so that I can follow up and take action. Radar also supports a large number of data sources. In addition to what you see here, you can connect to and scan other sources like Amazon S3, Docker images, or Terraform Cloud and Enterprise. I'll quickly walk you through the steps to connect to a new data source and then perform that first scan. First, I'll enter the organization, and I'm going to connect to GitHub Cloud. And then you can generate a GitHub token here if you don't have one, or go ahead and paste in your access token. Next, I can select to scan all the repositories or individual repositories that I want to select. I only have one here, and so I'm just going to scan all. And then once I click Finish, Vault Radar will start scanning that data source. I'm not going to at this point. I'll go ahead and cancel out because I've got plenty of repositories and data to work with. In addition to several GitHub repositories, I'm also scanning and managing a number of repositories that are running on premises. For these repositories, I chose to use my CLI or command line interface tool. After scanning these on-prem resources, my results automatically uploaded to HCP Vault Radar's UI for a consolidated view. When I click Events, then scroll down to Scanning Method, I can select CLI to only see the results of my on-premise resource scans. When I click on this event from my Confluence server, I'm taken directly to the page in Confluence where I can see a secret is exposed. Vault can also be scanned to create a data reference, so you can compare or correlate those managed secrets with unsecured secrets you discover in your scan. To see those results, select the Managed by Vault filtering option. With that information, I can remediate the problem by removing the secret from Confluence and rotating the managed secret in Vault. If the secret was not managed, I can add the secret to Vault so it can be managed and then remove it from Confluence. The next important step in my workflow is to enable a smooth handoff of scan results with the right dev teams for follow-up and remediation. I can see my world's best web app repository needs attention. By leveraging the HCP group capability, I can apply the right permissions via ABAC and RBAC to users that I'll call repo owners. Once I do this, these repo owners will be able to access HCP Vault Radar and only see the scan results for the repositories so they can remediate any issues. So at the org level, I'm going to go to Groups under Access Control, where I can see users that have already been invited to join the org and accepted. So I can add the appropriate users after I create my new group. I'm going to call it Team D. Give it a description. Then I can click Create Group to create that new group. Next, I'll add group members and add my 2 repo owners from World's Best Web App. Once that's done, I'll go to Projects, and I'm going to select the Vault Radar demo project where I want to add the new group. So do the same thing here, go to Access Control at the project level. And then I'm going to add the new group that I created to this project, which is Team D. And then I'm going to assign the role to that group, which is going to be project contributor. And that will limit these repo owners to just the repo that they should be managing. And then we'll jump back into resources in Vault Radar. And on this page, I can click on World's Best Web App, and then I can assign this team D with the users with the right permissions to that resource. And there you see it, team D in the column. HCP Vault Radar also provides integrations to route events that are generated to messaging, ticketing, and incident management tools. For example, Slack integration gives you real-time notification when someone tries to commit code with an exposed secret. And I'll show you how to configure that. First, I'll give it a name. I'm setting up a new connection. Then I'm going to use my Slack token that I already have to make that secure connection. Then the next thing I do is create a subscription. I'll give it a name. And then I can apply a filter to those alerts. Filters capture the events that are sent to the subscription, and you can use a default filter or create a custom one on the events page. I'm just going to use the default all events here. And then I'll select that connection I created. And then the last thing I need to do is enter the Slack channel where I want those alerts to show up. And then click test and save. And there we have it, it's created. Another powerful sprawl prevention capability is the pull request check. With this enabled, every pull request from monitored repositories is checked for exposed secrets. It's currently set to notify, but you can also set it to automatically block the PR from being merged. Also note there's a Radar app that gets installed on the GitHub repository to support the PR check capability, and I've already done this. Once I have this configured, I'll jump over to my cat generator repository and generate a pull request after I've uploaded a new file that contains a secret that we don't want exposed. As soon as I create the pull request, you can see Vault Radar begin to scan. And it finds the exposed secret. Here I can see details of what was found, the file path, found at the tip of the branch. And then I can click on the link to actually look at the secret where it was discovered. And since I configured Slack for notifications, I can jump over there and see a notification triggered by this event in the Vault Radar channel. At the top of it, there's a link to the event in HCP Vault Radar. So I can click that link to get the details of the who, when, and where of this exposed secret to triage it. At this point, I can mark it as triaged and then follow up with the owner to ensure they remediate the issue. There's a lot more to show if we had more time, but this gives you an idea of what your end-to-end workflow can look like using HCP Vault Radar when you're trying to find, manage, and prevent secret sprawl in your environments.
All right. So I hope that was useful. I think we saw a couple things from the Confluence, as well as the Git integration and Slack notifications that tell you the priority and take you directly also to the alert. Regarding when it comes to presentation, this has been everything for today. So thank you very much. But I'll now take a look at some of the questions that you might have. Okay, so we have first a question, which is, how are you determining the risk profile of a secret? So let me actually go back again to the presentation because it was one of the slides that we talked about. So yeah, these are the things that we take into account in order to prioritize the risk profile of each exposed secret, how active this secret is in case of GCP API keys, AWS credentials, GitHub access tokens, and JSON web tokens. We also take a look at the structure of the secret. We can then determine what type of secret it is, and related to that, how risky it is for it to be exposed. We also take a look at versioning control. So again, whether this is on the latest version and the production version of the code or not, this will entitle a higher risk profile for a secret or less. Then when it comes to the Vault integration, we can also determine when you're using like the whole Vault solution, let's say whether this is the latest version of the secret that is being exposed or not. In case that it's the latest version, it will be again a higher risk profile and more prioritized. And well, for remediation, we have seen many of the workflows that are being supported. So I hope that answers the question from Anonymous regarding how we determine the risk profile of a secret. To put it simply, how active is this secret active right now or not? What, according to its structure, what type of secret is it likely to be? Is it in the production or current version of the code? Is it the latest Vault version of the secret? And well, other parameters involved, of course. Then we have another question, which is with respect to proliferation, while scanning for plain text credentials in source code, can it scan all the versions of the code or just the latest version of the code? HCP Vault Radar does scan the whole repo, let's say. So it can include also previous version. Again, as you saw on the demo, there was one of the custom filters that had been activated, which was like is on the current version of the code. But you could also just set it to alert you regardless of the versioning. I hope this answers the question, Balakrishna. I can, in case it doesn't, we can maybe also follow up with some documentation. But yeah, that would be everything from my side. I will now hand it over back to Connor.
Thanks, Ignacio. Really appreciate the session. And as you say, it doesn't look like we have any other questions. So with that, we can conclude today's webinar. A big thank you to you, Ignacio, our speaker, for the presentation and demo, but as well to everyone in the audience for joining us. If you did find this session valuable, then you might also be interested in our next webinar that's taking place on the 10th of October, where we'll be looking at how to enable modern privileged access management with some other tools that we haven't discussed today, in particular HashiCorp Boundary and how that integrates with Vault. Just a reminder that this webinar was recorded, and we'll share that with you along with all of the slides that you saw today via email within the next 48 hours. So with that, thanks again for joining us. We hope you enjoyed today's session, and we look forward to seeing you next time. Thanks, everyone.
Thank you.